गुड मॉर्निंग गाइस, अ वेरी वेरी गुड मॉर्निंग टू ऑल ऑफ यू। कैसे हो आप लोग? हाउ आर यू डूइंग? बढ़िया बढ़िया। गुड आफ्टरनून स्मृति। So guys, in last session we started our discussion about the interview preparation series. I told you about the chemical reaction engineering and what type of question you can how you can relate the questions, the concepts with the daily life and some other stuff with some figures. Okay. So in last session we talked about the two questions, like first, how the refrigeration slow down the spoilage of food. We discussed that the proper kinetics and everything in proper details. Second, we also discussed about the catalytic converters used in cars or other motor vehicles to reduce the harmful emissions of the gases like carbon monoxide, nitrogen oxide, etc. Okay, and I also give you couple of questions to try to think about by yourself. So today we will start. We will discuss some questions like this. Third, the design equation of CSTR and how does the back mixing of a reactor performance. Then we will also talk about the advantages and disadvantages of each reactor type. Then this is one question which we will discuss here. You can say related to CRE, thermodynamics and mass transfer. All the three things. Like what if we talk about the gas liquid reactions, what are the thermodynamic considerations there, and how does the phase equilibrium and mass transfer limitations impact the reactor performance? Okay, this will be the question of the day for us in this session. And last, if we get the time, we will also discuss about this question. This question is mainly from the point of view of NPCIL, like discuss the principles. Let me write it as well for you. This question is especially from the point of view of NPCIL, because in BARC they are not going to talk you about the nuclear reactors that much. But anyways, so question is discuss the principles of chemical reaction engineering and thermodynamics that are applied in the design and operation of nuclear reactors, particularly focusing on the synthesis of nuclear fuels or reprocessing of spent fuel. Okay. So here obviously we will not go in much details of the nuclear reactors because that is not our cup of tea, but at least you should know the things from basic point of view. So this is what we are going to discuss. And now there will be few questions for you to think about, to prepare by yourself. And if you find any difficulty, you can let us know here in the live chat or in the comment box, or you can also mention in the Telegram group. So these three questions are for you. Try by yourself. And if you will find difficulty, we will discuss in the next session. So this is the seventh question. I hope all of you guys know about the exergy and energy concept. To explain the role of exergy analysis in evaluating the performance of chemical reactors and how can exergy loss be minimized in the industrial reactor setup. Okay. So any one of you know what is exergy here? Good afternoon, Ritik. Good afternoon. Any one of you know what is exergy and energy? I hope you have studied little bit of thermodynamics. So let me give you one basic idea, one in one line meaning, which will help you to think about this. Exergy we can define as the part of energy that can be converted into useful work. While exergy is the energy is the part of energy that can't be converted into work. Okay. If I try to explain this with a one simple example, so you can think like this. Suppose this is a thermodynamic system. I have supplied 100 joule of heat, and here system is giving me, let's say, 40 joule of work. So you can understand the change in internal energy will be 60 joule. So here you guys can see this 60 joule, basically 60 joule is the heat which is not converted into work. There, or you can say 60 out of 100 means 60% is energy, and 40 joule out of 100 means 40% is the exergy which has converted into work. So that's analysis you have to do. In chemical reactors, what is the role of exergy analysis and how the exergy loss can minimized, that also we have to discuss in industrial reactors. Okay, this is one very important question from the learning point of view. I hope you can understand this. Now, the next question here, which you also you have to try by yourself. And if you will be no find difficulty, we will discuss in the next sessions. So just let me know in that, either in the Telegram groups or here in the comment box. How do the principles of chemical reaction engineering and thermodynamics explain the processes involved in cooking and baking? ठीक है. Cooking and baking जो होता है, I hope all of you know, in COVID time, most of the people practice cooking and baking stuff, especially cooking things. Baking is a little bit different thing. I hope you have also tried that. So when we cook the food, you can understand some brownish color appear on the food surfaces. Okay, that is basically related to Maillard reactions. So you have to mention here the cooking and baking concept, the processes involved there, what are the reaction kinetics behind that, and the thermodynamic approach, thermodynamic analysis of those things. Okay, and the last question for you, which you can try by yourself. Suppose a reaction system with a specific kinetic data is given to you, like you can think like concentration and temperature data, or otherwise rate of reaction, all these type of things. So how will you design the appropriate reactor? How will you approach the problem? ठीक है. मतलब हम मैं आपसे बोलूं, suppose all of us are have forming a group and we have decided that we will set up this industry. For example, suppose we decided that we will set up one ammonia plant. तो हमारा product ammonia है. We want to produce ammonia, and we know we will decide some capacity for us depending on the demand and supply concept and so many other factors. So ammonia synthesis reaction, you know, N2 plus S2 gives NS3. So their reaction kinetics will be available to you, the rate equations or apparent order data. So you have to decide how and what type of reactors we have to design. Like batch reactors are there, MFRs are there, PFRs are there. So which reactor we will choose? And you have to also answer this. Why you have chosen that reactor? What was the basis of your selection? Okay. So these are the questions, guys, for you. Try by yourself. Okay. And if you will not be able to find out any good answer, just let me know in the comment box of the video or otherwise in the Telegram groups. And I will explain in the next classes. So for today, let's start the discussion with one simple question. This one. These two we have already done in the session one. So if any one of you have missed the first session, you can check. And for today, we will start from this. Drive the design equation for a CSTR and how does back mixing affects the reactor performance. So I'm giving you couple of minutes. Try by yourself, find out the design equations of CSTR and think how the back mixing affects the reactor performance. And let me know if you have done that. Otherwise, we will discuss. Okay, now let's see. Suppose we have a CSTR, a feed entering with initial concentration Ca naught and leaving and molar flow rate Fa naught, volumetric flow rate V naught, and leaving with final concentration CAF, volumetric flow rate V is equal to V naught, conversion XA is obtained, and the final molar flow rate of A is Fa. Let's say some reaction is A gives P, and the volume of reactor is suppose Vm. So here when we will talk about the designing of CSTR, all the design equations, all the reactor problems we can solve with the help of mole balance. But here one thing is one assumption, certain assumptions we will consider. Like first, the process is at steady state. This is one important assumption in flow reactors. You guys know that we try that continuous flow reactors operating shall operate at steady state condition. Second assumption you can think like the density of reaction mixture may remain same and or constant you can say throughout the reaction. So these are two main assumptions, guys, and I hope the other stuff you already know. Here, when you will do the things, when you will apply the mole balance over component A, So here you guys know that this is a CSTR, and in CSTR we do have this perfect mixing concept. This is also one assumption you can write. The we have a perfect mixing here. Okay, so when you will write the mole balance over A, then here you know that due to the perfect mixing, the concentration of any component inside the reactor will be same as that of at outlet. That means concentration of A inside the reactor Ca will be same as that of at outlet Cf. Okay. Anyways, this is the benefit of having this third assumption. The mole balance over A, when you will write, you know the equation. What is the general mole balance equation? Molar rate of A in is equal to molar rate of A out plus molar rate of A accumulation plus molar rate of A disappearance minus molar rate of A generation. So here you guys know molar rate of A in Fa naught, molar rate of A out Fa. Accumulation term will be 0 since it is operating at steady state. Molar rate of disappearance of A will be minus dNA by dt, and generation term will be 0, or you can neglect that because A is just reacting, not getting generated. Okay, and here you know that why we are able to write down the mole balance for entire reactor. This is the question. Before we move ahead, if I ask, if they ask, why in CSTR we are writing the mole balance for overall reactor, while in case of PFR we do it on a differential plug, a differential fluid element. But here we are able to do it for entire reactor. Why? Any answer would you like to give? Correct. That's what you can say. Because in MFR, concentration distribution is uniform. And uniform concentration distribution means throughout the reactor at each and every point, concentration is same. So even if you do the mole balance at a particular point or for entire reactor, the result will remain same due thanks to this assumption, perfect mixing. And if you will not take this assumption, perfect mixing, then you will not be able to do it for entire reactor. Then you have to do it on one particular globule, and with the help of that, you have to find out for entire reactor, like we do in segregation model. I hope you guys know. Okay, so here now, maybe if any one of you is wondering why we have written rate of disappearance of A like this, so this is the actual meaning of rate of disappearance of A, molar rate of disappearance of A. I hope you know this. In the first lecture of CRE, we learn about this molar rate of disappearance of A. And by the definition of rate of reaction for homogeneous reaction system, you know that minus dNA by dt can be written as minus Ra into V. So here you guys can see Fa naught minus Fa will become minus Ra into V. Now here, you know, Fa naught minus Fa can be written as Fa naught into Xa. This is minus Ra into V. And what is this V here? This V here, I hope you guys know, it is the volume of reaction mixture. Okay. So now if you rearrange this, you can write it as V by Fa naught equal to Xa over minus Ra. And when we do write like this, so here we can say this V is not the volume of reaction mixture. With respect to reactor, we can say this V is actually the theoretical volume of MFR required or reactor required, or you can say the minimum volume of reactor required. I hope this is clear to all of you. This is the design equation, and all of you already know that. Now, here, can any one of you tell me why this V, which was the volume of reaction mixture, now we are taking as theoretical volume of reactor? Why? Yes, because inside the reactor concentration was same. Correct, Amit. But now for this question, answer. Why the volume of MFR we have taken as volume of, sorry, volume of reaction mixture we have taken as volume of MFR. It's very simple, guys. Suppose I have 100 ml water, and if I want to store it or handle it in a container, so for 100 ml water, or you can say 100 ml solution, what shall be the minimum volume of container needed? You will say 100 ml. If I say I have 1 liter solution, the minimum volume of container shall be 1 liter. So similarly, if we have V volume of mixture, so the volume of container shall be, minimum volume of container shall be V. So this is the reason we take V as volume of MFR. And in this case, if you draw this equation, this is called the design equation of MFR, or you can say the performance equation of MFR. And when you plot this equation on a graph between 1 upon minus Ra versus Xa, so you know that for any positive order reaction, the curve is something like this. And let's say this is the conversion XAF. So here, can you guys tell me what will be the area of CSTR on this performance curve? Area governed by the CSTR on this performance curve. Uh, You are answering the value. I mean the nature of the area. Area governed by the curve. What will be the nature of that area? Like in batch reactor, we have area under the curve. So here, what will be the nature of the area? Which area will be the area of CS3R, basically? You guys are saying rectangular. Okay. Why? Why this area is rectangular here? Come on, guys, you can do better. Any idea to anyone? In case you don't have any idea, बिकॉज इंटीग्रल इक्वेशन नहीं है पीएफआर के जैसे नो वो तो ठीक है नहीं है बट व्हाट इज द आंसर अगर कोई आपसे पूछेगा इस समय दिन क्यों है तो आप ये थोड़ी बोलोगे क्योंकि रात नहीं है इसलिए दिन है आपको ये बताना है ना कि दिन क्यों है आई होप यू आर अंडरस्टैंडिंग द डिफरेंस बिकॉज इफ यू लुक एट द परफॉर्मेंस इक्वेशन हियर व्हाट इज दिस परफॉर्मेंस इक्वेशन एक्स ए इंटू वन अपॉन माइनस आर ए and xa means x-axis 1 upon minus ra means y-axis. What is this? This is the equation of area of a rectangle. That's the only answer. In MFR, in the design equation, we can see the performance equation represents the equation of an area of an rectangle. Okay? That's why here we will consider the rectangular area. And mathematically, that will be equal to V by F A naught, or you can say tau by C A naught. You know that because tau is equal to V upon V naught, or you can say V into C A naught over F A naught, where tau is the space time. अगर यहाँ पे ये परफॉर्मेंस कर्व में if this equation was something like 1 by 2 xa into 1 upon minus ra, so we would have seen half into base into height, something like that. तो ये एरिया का जो शेप है वो ट्राइंगुलर होता. That's how you have to think like this. That's how you have to think. ठीक है? In performance curve here, performance equation, this is the equation of area of a rectangle. That's why the performance curve area governed by the CSTR will be the rectangular area. I hope it is clear now. Same concentration? No. Area has nothing to do with concentration. Is it clear now? Why we consider rectangular area? Because of the performance equation. Yes, okay. Now, the next, let's move to the question. Question was derive the design equation of CSTR. We have done that, and the equation was something like this: V by Fn naught is equal to Xa over minus Ra. Now, the next point is what is the effect of back mixing on reactor performance? So, here, guys, you know that when we talk about the PFR and when we talk about the CSTR, the initial concentration is Ca naught, final is CF. Okay. These are two different cases. Don't think that this CF and this CF are same. It is just a case. Uh, And you all already know for any positive order reaction, conversion obtained in PFR is greater than that of in MFR for same volume. For positive order reaction, if you compare the reactors of same volume like MFR and PFR, so PFR will give you more conversion than MFR. You know that. So here what happens in CSTR, if you look throughout the reactor due to back mixing, throughout the reactor we have uniform concentration distribution. Second thing is concentration inside the reactor is same as that of at outlet. Okay, I hope you can understand this. Now what happens due to all this stuff, when you look at the rate of reaction, you guys know that rate of reaction is proportional to rate of change of concentration. Up to some extent you can think like this. So if concentration is high, or otherwise if you don't want to go like this, you can look at the Power's law. R is equal to K Ca power n. You can think like this. So if concentration is high, rate of reaction will be high, and if concentration is low, rate of reaction will be low. So throughout this MFR, what is the average concentration inside the reactor? Same as CF. The average concentration inside the reactor Ca bar will be same as the exit concentration, and exit concentration in MFR is the lowest possible concentration क्योंकि फर्दर तो रिड्यूस नहीं हो रहा ना CF तक ही रिड्यूस हो रहा है इसके आगे रिड्यूस नहीं हो रहा so that means in CSTR the rate of reaction is quite low, especially if I talk about the positive order reactions. For positive order reactions, we can see R is proportional to Ca power n. So as Ca will increase, R will increase, Ca decreases, R decreases. Rate of reaction. So here you can see in CSTR, the average concentration inside the reactor Ca bar is equal to Cf, which is the lowest possible concentration for the desired system. So that means the rate of reaction inside the reactor will be quite low, a small value that cause the smaller conversion. Okay, but if you look in PFR, if you compare this from PFR, so you know that in PFR concentration distribution is non-uniform. है ना? So what happens? Concentration at the inlet is Ca naught. That means rate of reaction at inlet is maximum. And further, as reaction mixture moves along the length of the reactor, concentration decreases along the length. And since concentration decreases along the length, but ultimately, if you think mathematically, if you think here, concentration inside the reactor is always greater than at any point. Concentration inside the reactor at any point is always greater than the concentration at exit, that is CF. So throughout the reactor in PFR, we have gradual concentration drop in axial direction. That's why the rate of reaction will be relatively high in PFR as compared to MFR. That's why for positive order reactions, or even after having the same volume, PFR gives high conversion than MFR. ठीक है? That's how the back mixing affects the reactor performance. In PFR, we don't have back mixing. So that's why concentration drop is gradual. So that's why the rate of reaction along the length of the reactor will decrease. But relatively, it will be higher than that of in case of PFR. Because in case of MFR. Because in MFR, due to uniform concentration here, the rate of reaction will be smaller since this concentration inside the MFR is same as that of at outlet. But in case of PFR, we have gradual concentration drop. Rate of reaction is maximum at the inlet, but ultimately it is decreasing. But still, it is maximum at inlet. MFR में तो maximum है ही नहीं. MFR में कहाँ बोलोगे आप maximum है? Where is maximum in MFR? Nowhere. Because even in MFR, you can understand this is Ca naught, this is CAF. You can think like this. This is Ca naught. Throughout the reactor, we have uniform concentration. Uniform concentration. So the moment this Ca naught will enter in the reactor and comes in contact with the mixture, it will reduce to CAF. It will reduce to CF. That means in case of MFR, we have a very rapid concentration drop, a very fast concentration drop. तो अल्टीमेटली यहाँ पे आप बोल ही नहीं सकते कि इनलेट पर सी नॉट ज्यादा है, रेट ऑफ रिएक्शन मैक्सिमम है, नहीं. Because here we don't have any Ca naught. The moment Ca naught enters in MFR, comes in contact with mixture, it converts at the same instance. It converts into CF because of the perfect mixing, because of the back mixing. So if you compare MFR and PFR, this is the reason. In MFR, concentration is uh, low at lowest possible value. That's why rate of reaction is low. That's why the conversion obtained is low as compared to PFR. And similarly, आपने सुना होगा that for negative order reaction for the same volume, MFR gives high conversion than PFR. उल्टा हो जाता है. Why? The same reason. In MFR, we have small Ca inside the reactor. And if Ca is small and rate of reaction for negative order reaction means R is proportional to something like this, inversely proportional to Ca. तो सी ए जितना कम होगा आर उतना ज्यादा होगा, आर जितना ज्यादा होगा कन्वर्जन भी उतना ज्यादा होगा। और एम एफ आर में कन्वर्जन ज्यादा मिलता है, पी एफ आर में कन्वर्जन कम मिलता है। ठीक है, तो आई होप इट इज क्लियर नाउ। बैक मिक्सिंग विल नॉट अफेक्ट द कन्वर्जन, क्या बात कर रहे हो? एम एफ आर और पी एफ आर में यही तो एक डिफरेंस है बैक मिक्सिंग का। आई होप यू अंडरस्टैंड बैक मिक्सिंग कॉन्सेप्ट नाउ। बैक मिक्सिंग मीन्स काइंड ऑफ recycling. So in case of MFR, internal recycling is there. Guys, मैंने कुछ ज़्यादा एडवांस तो नहीं बता दिया, ये सब चीज़ें बेसिक हैं। This is MFR. Think like this. This is inlet, this is outlet. Molecules are entering. Now they are supposed to get mixed and leave. This is the logic. This is the idea behind it. Enter, mix, and then leave. है ना? Impeller is rotating. You know the rotational speed is there. So due to this, what will happen? The molecules which are here near the outlet, they are supposed to leave. They are supposed to leave. But due to the rotation of the impeller, due to the back mixing, what happens? Some of these molecules will move in backward direction, this, and interact with the new molecules, fresh molecules. This is what we call back mixing, like we do recycling. So recycling is nothing but back mixing. And in case of CSTR, back mixing is very high internally. In MFR, there is no back mixing. That's why along the length of the reactor in axial direction, concentration changes. I hope now it is clear to all of you and you will not get confused. ठीक है? Okay. Now let's get move to the second question. What are the advantages and disadvantages of each reactor type? Here you don't need to go in much details. Just talk about only three: batch reactor, plug flow reactor, and mixed flow reactor. Hello, Zakir. That's why we prefer PFR in autocatalytic reactions. Hmm. Autocatalytic reaction, we prefer MFR and PFR both. It depends on the desired conversion. आपने ऑटोकैटालिटिक रिएक्शन का काइनेटिक्स पढ़ा होगा, तो you know that how the performance curve looks. So if the desired conversion for autocatalytic reaction is up to 50%, 50, then we prefer MFR. But if the desired conversion in autocatalytic reactions is more than 50%, then we prefer MFR followed by PFR. Up to 50% MFR and then after that PFR till the desired value. ठीक है? I hope it is clear now. Just give me a minute, guys. Hello. Yes, guys. So we were talking about the advantages and disadvantages of different type of reactors, MFR, PFR. So you know that in MFR we have uniform concentration throughout the reactor. So we can maintain uniform concentration, uniform temperature, uniform rate of reaction. So it is easy to control because you know that if I talk about homogeneous and heterogeneous mixtures, yeah, or homogeneous and heterogeneous conditions, so which are easy to control? किसे कंट्रोल करना इजी होगा? Obviously homogeneous things, है ना? And if we talk about the scalability कि आप उसे large scale production के लिए use कर सकते हो नहीं कर सकते, तो MFRs are the best choice. Steady state operation easily operate हम obtain कर सकते हैं. Process dynamics control में भी आपने पढ़ा होगा about the steady state processes, especially in the mixing tanks when we have to check the steady state with the based on height of the mixture, level of the mixture inside the tank, है ना? But if we talk about the disadvantages, so in MFR the disadvantages are conversion कम होता है as compared to PFR for positive order reactions. Non ideality ज़्यादा होती है as compared to PFR and other reactors. Means residence time distribution is high, variance is high. ठीक है? And if we talk about the size, so for the given conversion in positive order reactions, for the given conversion, MFR needs large volume as compared to PFR. Similarly, आप PFR के लिए बोल सकते हो कि PFR में for positive order reactions, conversion obtained is more as compared to MFR for the same volume. In case of PFR, since conversion efficiency is also high because concentration gradient is there, concentration changes gradually. So if anything is happening gradually, so obviously you can think, you can understand, it will be more efficient. है ना? इसे आप एक simple example से समझ सकते हो. If you are driving a car or bike on a road at high speed, and suppose if there is a sharp turn and you have to take your car vehicle there, so what will you do? If you want to control your vehicle smoothly, if you want to drive efficiently, you have to slow down the vehicle, है ना? Otherwise, so this happens in PFR. We have high efficiency as compared to MFR, and advantages is that due to very low non-ideality, PFRs are considered as ideal reactors. Suppose आपको अगर अपने लिए if you want to get married, तो obviously you will look for some qualities in your spouse and you have that checklist in your mind and you will see and you will also have some checklist of bad qualities that my spouse should not have these things है ना क्वालिटी तो नहीं पता चलती जल्दी, बट बैड क्वालिटी हमें जल्दी पता चल जाती हैं। तो आप चेक करोगे उसमें जो बैड क्वालिटीज हैं। फॉर एग्जाम्पल, क्या वो स्मोक करता है? नहीं। क्या वो ड्रिंक करता है? नहीं। क्या वो हम्बल, क्या वो काइंड है? यस। लाइक दिस। तो व्हेन यू विल सी, कोई नॉन आइडियलिटी उसमें है ही नहीं, वो जुआ भी नहीं खेलता, बैट भी नहीं लगाता, कुछ ऐसी चीजें नहीं करता। तो व्हाट विल यू से? व्हेन वी हैव अ ह्यूमन एंड बैड क्वालिटी नहीं है, तो वी विल थिंक लाइक दैट इट इज अ आइडियल पर्सन। तो सिमिलरली पीएफआर में कोई नॉन आइडियलिटी नहीं होती, ना डेड जोन होता है, ना टर्बुलेंस होती है, ना बाईपासिंग की प्रॉब्लम है। तो पीएफआर इज लाइक अ आइडियल रिएक्टर, है ना? एंड इफ वी टॉक अबाउट द साइज, तो फॉर पॉजिटिव ऑर्डर रिएक्शंस, for same conversion, MFR needs large volume, PFR needs a small volume. So PFR is kind of a, you can say, a small volume of less floor space, compact design, you can say, है ना? और if we talk about the disadvantages, so PFR are more complex than CSTR to control. ठीक है, थोड़ा डिफिकल्ट होते हैं, बिकॉज इन सी एस टी आर वी हैव होमोजीनियस कंडीशंस, यूनिफॉर्म टेम्परेचर कंसंट्रेशन, तो इजी टू कंट्रोल, बट इन पी एफ आर वी हैव नॉन यूनिफॉर्म टेम्परेचर कंसंट्रेशन, तो लिटिल बिट डिफिकल्ट टू कंट्रोल। एंड स्केलिंग ऑफ पी एफ आर इज लिटिल बिट ट्रिकी एज कम्पेयर टू एम एफ आर। एम एफ आर की स्पेलिंग ज़्यादा, स्केलिंग इज मोर प्रेफरेबल, मतलब ईजी है एज कम्पेयर टू पी एफ आर। ठीक है, that's how you can think. And about the batch reactor, you know, batch reactors are preferred for slow reactions, small scale productions, high conversions, control, product quality, all these things. Disadvantages are time consuming, discontinuous operation, maintenance cost is high, like this. So you can think about all these things, advantages and disadvantages. Okay. If you people will like, I will give you a handout on this, advantages and disadvantages of PFR. So you can see from there. So I hope all these things are clear. When we use recycling in feed in autocatalytic reaction, in autocatalytic reaction अगर आप recycling कर रहे हो तो वो PFR में करते हैं. And if you do recycling in PFR, तो it acts like a MFR for high recycle ratio. Yeah. If we use recycling in MFR, MFR is not a recycle reactor. First of all, PFR with recycle stream is considered as an ideal as a recycle reactor. थर्ड थिंग इज, एमएफआर में अगर आप एक्सटर्नल रिसाइकलिंग करते भी हो तो उसका एज सच कोई इफेक्ट नहीं होगा, बिकॉज ऑफ वेरी हाई डिग्री ऑफ बैक मिक्सिंग। ठीक है, लाइक इफ यू सी, दिस इज पीएफआर, हियर इफ यू डू बैक रिसाइकलिंग, एक्सटर्नल रिसाइकलिंग, इट इज अ रिसाइकल रिएक्टर, इट इज ऑल्सो कॉल्ड रियोर रिसाइकल रिएक्टर। तो आपने क्या किया, बेसिकली आपने एक बैक मिक्सिंग का कॉन्सेप्ट, कैरेक्टरिस्टिक इसमें डेवलप कर दिया। ठीक है, टू मेक द कंसंट्रेशन मोर एंड मोर यूनिफॉर्म। And now this PFR with recycle stream will act like a MFR. बट जब हम MFR की बात करते हैं तो इन केस ऑफ MFR, इंटरनल रिसाइकलिंग ही इतनी ज़्यादा हाई होती है कि एक्सटर्नल रिसाइकलिंग का एज सच कोई इफेक्ट नहीं होता। ठीक है, तो कन्वर्जन हमारा ऑलमोस्ट सेम रहता है, बिकॉज द इंटरनल रिसाइकलिंग इज क्वाइट हाई, so there is no effect of some external recycling. I hope it is clear now, Richa and all of you. ठीक है, तो अब थर्ड क्वेश्चन की तरफ मूव करते हैं। वैसे थर्ड क्वेश्चन से याद आया, मैंने कल आप लोगों को एक क्वेश्चन बोला था, आई होप आपने देखा होगा, व्हाट इज द रिएक्शन काइनेटिक्स बिहाइंड द क्लीनिंग और वॉशिंग ऑफ क्लोथ्स? हैव यू सीन दैट? डू यू वांट टू डिस्कस एनीथिंग? यस, थैंक यू। ओके सर, एक बार बता दीजिए। अच्छा, वो क्लीनिंग वाला तो नहीं जी आया समझ में आपको। चलो, वी विल टॉक अबाउट दैट। अभी इस क्वेश्चन की बात करते हैं, देन वी विल टॉक अबाउट द दैट क्वेश्चन, है ना। डिस्क्राइब द thermodynamic considerations in designing a reactor for a gas liquid reactions. How do phase equilibrium and mass transfer limitations affect the reactor performance? इसके लिए मैं आपको सजेस्ट करूंगा, मैं here I will give you a brief idea which will be sufficient to help you understand all the things. But still, if any one of you want to study this topic in more details, you can see this topic, Hatta modulus, in little detail. You can read from it. ठीक है? Or otherwise, if you are not interested to do that, or even after you reading, if by chance you are not able to understand, just let me know in your group, in the Telegram group or anywhere, or in the comment box. I will discuss this particular topic in proper details. ठीक है? क्योंकि ये एक छोटा सा क्वेश्चन आपको लग रहा है, बट एक्चुअल में ये पूरा अपना एक टॉपिक है, जिसे हम ऐसे आधे घंटे में 15 मिनट में बात इसकी नहीं कर पाएंगे इतना इफेक्टिवली। ठीक है, बट स्टिल आई विल ट्राई कि हम कम टाइम में कैसे आपको इसे एक्सप्लेन करें। तो अगर आपको इसके बारे में ज़्यादा जानना हो, क्योंकि ये दिस इज़ वन ऑफ द इम्पॉर्टेंट टॉपिक फ्रॉम योर इंटरव्यू पॉइंट ऑफ व्यू, क्योंकि यहाँ पे आपका सीआरई, मास ट्रांसफर, थर्मोडायनेमिक्स तीनों आ जाते हैं। तो लेट्स टेक वन सिंपल एग्जांपल ऑफ केमिसॉर्प्शन रिएक्शंस। ठीक है, केमिसॉर्प्शन बोल सकते हो, और यू कैन से केमिसॉर्प्शन रिएक्शंस, डजंट मैटर। अगर एक सिंपल आइडिया लें तो आप इसे, if you want to understand this properly, you can think about a gas absorption. For example, in mass transfer, we study gas absorption. And if I ask you to draw the two film theory, the profile, concentration profile of the gas absorption, how will you do? So this is something like interface, we can say. Here we have suppose gas bulk or gas phase. This is gas film. Here we have liquid film, and this is liquid bulk or liquid phase, you can say. So if I am talking about the gas absorption, then you guys already know gas absorption means molecules will move from gas to liquid. So suppose the concentration of A is the component in gas phase is CHG. Then you know mass transfer will occur across the gas film from bulk to interface. Let's say at gas interface the concentration is CAI. Then at interface the liquid phase concentration is, or let's me do one thing, sorry, instead of writing Ca, let's do write Pa. Pag in gas, Pai at liquid gas interface. For liquid interface it is Cai, and in liquid bulk it is Cal. Now here, suppose A is the solute, so what will happen first? A will transport from gas bulk to interface. gas interface. Then A will transport, the interface mass transfer will occur, and A will move from gas to liquid at interface. Then third, now there are two possibilities. First, reaction may occur. Suppose A is the reactant. The reaction may occur at interface, or otherwise, second, reaction may occur in the liquid bulk. So that will be like A will move to liquid bulk and then react inside the liquid bulk. So this is your, if A is reacting, then it is your chemist option. And if A is not reacting, just getting absorbing, so that is gas absorption. So this is the profile, you know, a basic idea. Now, if you want to study this, suppose the reaction kinetics is something like this, KCA. Now, this Ca could be equal to Cai, or this Ca could be equal to the concentration of A inside the liquid bulk. But what will be the value of this Ca? So you can understand the value of this Ca will totally depend on the mass transfer between the gas phase and liquid phase. And for the mass transfer, to study the mass transfer phase and gas phase, you can understand basically the mass transfer step is very important here. है ना? So, how the mass transfer will occur? For that, need to use the thermodynamic laws to study the mass transfer. And those thermodynamic laws are Henry's law and Raoult's law. You know that Henry's law is like Pa is equal to KCA. Raoult's law is something like Pa is equal to Ca into PAV, or you can say Xa into PAV, it doesn't matter. Something like this. And this is what I have written in ideal form. ठीक है, these are the Henry's law and Raoult's law in their ideal form. Actual में क्या होते हैं, you know that. In actual they are completely different, which you have already seen in thermodynamics. है ना? So with the help of these, we can study the equilibrium, the extent of mass transfer that will occur from gas phase to liquid phase. And then if you want to study the rate of mass transfer, then you know rate of mass transfer you can calculate or define with the help of flux, with the help of mass transfer coefficient, where kg is the gas film side mass transfer coefficient. So that's how you can understand. Okay? That mass transfer coefficient here will give you the limitations, the mass transfer resistance. It is also one parameter which we will use for the resistance, and second we will use this because Henry's law and Raoult's law, these type of things will help us to figure out the extent of reaction. Basically, they will help us to figure out the distribution of A in different phases. ठीक है, like गैस फेज में ए ज्यादा है, लिक्विड फेज में ए ज्यादा है, कहाँ पर ज्यादा है? And you can understand if A is more in liquid phase, then reaction will occur more, rate of reaction will be more, है ना? So these are the things, guys. ठीक है, so here I am giving you just a basic idea. So I have suggested you study this Hatta modulus part, this topic from your book. And by chance, if you think you need the details, then let me know in the groups or in the comment box. I will create, I will take one separate session only for this particular topic of gas liquid reactions. Okay. अभी मैंने आपको एक ब्रीफ आइडिया दे दिया है कि आप कैसे इसे समझ सकते हो, क्या हो सकता है। ठीक है, हाउ द प्रोफाइल्स विल बी देयर. So guys, is it clear? सर रट्टा मॉडलर समझ नहीं आया था अच्छे से. ओके, तो वी विल डू दैट. तो हियर नाउ लेट मी गिव यू द वन लास्ट डिस्कशन. आपने जो क्वेश्चन पूछा था पहले उसके बारे में बात कर लेते हैं फ्रॉम लास्ट सेशन. ठीक है, अबाउट द रिएक्शन मैकेनिज्म और रिएक्शन काइनेटिक्स बिहाइंड क्लीनिंग ऑफ डर्टी क्लोथ्स. क्लीनिंग और वॉशिंग ऑफ डर्टी क्लोथ्स. ठीक है, अब आप ये मत सोचना. सी अगेन आई एम रिपीटिंग, वी आर डिस्कसिंग दिस. इज डजंट मीन दैट इन इंटरव्यूज और समवेयर दे विल आस्क यू दिस टाइप ऑफ क्वेश्चन और नॉट. ठीक है, और व्हाट इज द पॉइंट? सी द आइडिया इज, you just maybe you have seen that listen that video which audio which Ankur sir just posted on the Unacademy channel yesterday. Okay, about the interview experience of the guy, and in mock interview sessions also we have told you so many times. In Bark, they will start the discussion from your favorite subjects. Okay, they will. It is a very rare chance they will ask you anything which is out of your favorite subject. But the idea is they will always start from the very basic questions, and they will ask you very basic question, then you will answer, then they will ask, then you all answer. If your answer is satisfactory, they will jump to the next question, and if your answer is not satisfactory, they might ask you the cross questions. And in this entire discussion, that's how they will move for some advanced question. But ultimately the whole idea is you should be able to relate the things with daily life, daily life examples, daily life applications. That would be more appropriate, because if you are able to do those such things, then it will show one great impression. ठीक है, कि हाँ ये बंदा एक्चुअल में रिलेट करता है चीजों को, एंड ही हैज अ गुड नॉलेज. एंड व्हाट इज द रोल ऑफ अ साइंटिस्ट? यू नो दैट अल्टीमेटली साइंटिस्ट करते क्या हैं? यही तो करते हैं. दे स्टडी द नेचर, what is happening in our surroundings, how we can analyze those things, why they are happening, why not. यही तो करते हैं. तो यहाँ पर भी आपको यही करना है, इसलिए यू शुड आंसर लाइक दीज थिंग्स. ठीक है, दैट्स व्हाई वी आर डिस्कसिंग दिस टाइप ऑफ क्वेश्चंस. बेकिंग, कुकिंग, spoilage of foods. ठीक है, there is no other way of explaining, relating the CRE concepts with daily life. And if there will be any other, so I will explain that also. ठीक है, तो that's why I am telling you, don't mind all these things. Just think कि अगर किसी के माइंड में ऐसा थॉट आता है कि यार कपड़े धोना ये कैसी साइंस, ये कैसे, इसमें क्या सीआरई है? कपड़े धोना ही तो सबसे बड़ी सीआरई है गाइस. यू नो अबाउट द डिटर्जेंट इंडस्ट्री, सोप इंडस्ट्री. ठीक है, तो व्हाट इज द मेन इंग्रेडिएंट इन दीज सोप्स और डिटर्जेंट्स? इनमें ऐसा क्या होता है जो इस चीज को हेल्प करता है? यू नो, द सर्फेक्टेंट्स आर देयर. And if you know about the surfactants, then you know that these surfactant molecules actually have two ends. One end will be kind of hydrophobic, that is what you can say, kind of water repelling. And second is hydrophilic, that is kind of water loving, you can say. And if I talk about the dirt, dirty clothes, so what is the dirt in clothes? Dirt or stain. What is the main component in them? So if you have idea, so in dirt and stain, the main they have kind of a grease, oils, or fats, most of them, as a ingredient, as a main ingredient. ठीक है? So होता क्या है? When we add the surfactants in the, or the detergent powder in the water, and then the clothes in them, so what happens? The surfactant molecules, they have two ends, kind of hydrophilic ends and hydrophobic ends. So hydrophilic ends are water attracting, so they will attract the water molecules. And hydrophobic ends will repel the water, but they will attract, or they will absorb the oil and fat molecules there. Okay. तो जो भी आपके dirt particles हैं या stain है in clothes, तो what happen in that stain? We will have some moisture, we will have some oil. तो उस stain में जो oily fat particles हैं, they will be get absorbed, attached towards the hydrophobic end, and जो water part molecules हैं, they will get attached towards the hydrophilic end. That's how the dirt particles, that dirt, the stain will break down. Okay. And if we talk about their kinetics, so you can think like this. Suppose this is the surfactant. So at one end, which is hydrophobic, oil and fats, these type of molecules will get attracted. And on the other hand, which is hydrophilic, water and H2O molecules will get attracted. Basically, the adsorption will occur. Okay. And in this adsorption, if you wish, you can use La isotherm to understand or to explain these things. ठीक है? Allo isotherm you can write. I hope you know about Allo isotherm. So it will be something like rate of adsorption equal to rate of desorption. So d theta over dt you can write as adsorption constant 1 minus theta s Ca or CS you can say, a minus desorption constant into theta s, something like this. Rate of adsorption minus rate of desorption, that is net change of adsorption. I hope you know that, the LA isotherm, Langmuir adsorption isotherm. Okay, you can do the things from there. Then what happens? Micelle formation occurs. Micelles or micelles, whatever you like to say or pronounce. Okay, what micelles are, you know that they get aggregate with the concentrations of those, and these aggregations will result in micelles encapsulations. ठीक है, मिसेल जो है, जो भी डर्ट पार्टिकल्स हैं जो हाइड्रोफोबिक एंड की तरफ हैं, वो एक एग्रीगेशन होना स्टार्ट कर देंगे सरफेक्टेंट्स में, एंड दे विल फॉर्म काइंड ऑफ अ मिसेल्स. ठीक है, या फिर आप बोल सकते हो जो सरफेक्टेंट्स में जब साबुन या डिटर्जेंट बनाते हैं वहां जो बबल्स फॉर्म होते हैं उनके अंदर एनकैप्सुलेट हो जाएंगे. दैट्स हाउ यू कैन थिंक लाइक दैट. ठीक है, and after that, all the other things, saponification reaction can be there, emulsification can reactions can be there, solubilization reactions can be there, all these things. ठीक है, तो इतना भी अगर आप बोल दोगे सफिशिएंट है, पूरा आपको डिटेल में जाने की नीड नहीं है. ओके, बट आपको ये चार चीजें पता होनी चाहिए कि सरफेक्टेंट एड्सॉर्प्शन कैसे होता है, मिसेल फॉर्मेशन कैसे होता है, और जो सरफेक्टेंट, जो डर्ट पार्टिकल्स होते हैं, स्टेन पार्टिकल्स होते हैं, हाउ दे ब्रेक डाउन. ठीक है, थ्री, these three things you should know mainly to answer this. अदरवाइज इसमें भी आपको अगर ज़्यादा डिटेल में जाना चाहोगे तो पूरा आप लंबा जा सकते हो, कोई इशू नहीं. ओके, तो हट्टा मॉडलर्स के लिए हम सेपरेट सेशन देखते हैं. वी विल सी. थर्सडे फ्राइडे तो हमारा ये सेशन है, तो हम सैटरडे संडे या मंडे में ट्राई कर लेते हैं किसी दिन. व्हेन यू हैव योर इंटरव्यू, इन जून और इन मई? अगर जून में है तो हम आराम से संडे मंडे में कर सकते हैं, और अगर इसी मंथ है आपका 11 जून, हाँ तो फिर सैटरडे संडे मंडे के आसपास कर लेंगे. आई विल इन्फॉर्म यू गाइस इन द टेलीग्राम ग्रुप, तो जो मेरा टेलीग्राम ग्रुप है आप उसे ज्वाइन कर लेना. ठीक है गाइस, बाकी इससे पहले हम आगे बढ़ें, तो मैंने आपको कुछ क्वेश्चन स्टार्टिंग में बताए थे विच यू कैन ट्राई बाय योर सेल्फ, एंड इफ यू फाइंड डिफिकल्ट वी कैन डिस्कस इन द नेक्स्ट सेशंस. These were the questions, like what is the role of exergy analysis in reactors, and how exergy loss can be minimized in the industrial reactors. Second was this, what is the principle of chemical reaction engineering and thermodynamics in cooking and baking. Third question, this you can try by yourself. If we have the reaction kinetics data and the reactions with us, how can we design a reactor? ठीक है. So guys, I hope it is clear to all of you. बाकी आप लोगों के लिए एक और इन्फॉर्मेशन है मेरे पास. ठीक है, विच आई लाइक टू टेल ऑल ऑफ यू. ऑन अनअकैडमी वन ऑफर हैज स्टार्टेड अगेन. ठीक है, दिस ऑफर हैज बीन स्टार्टेड अगेन फ्रॉम टुडे for 9 months, for all the people who are going to plan for gate 25 preparations. ठीक है, if you want to subscribe for the 9 month course using my code, that is ACE009, so you will get you can access that thing in 12,999. If you want to get the course subscription for 12 months, 3 months extra, 3,000, 2,000 extra, मीन्स 1,000 रुपीज का ऑफ है। ठीक है, आपको 14,999 में वो प्राइस आपको पे सब्सक्रिप्शन मिल जाएगा। एंड अगर आप लोग 24 मंथ्स के लिए सब्सक्रिप्शन लेना चाहते हो तो यू जस्ट नीड टू पे 24,999 रुपीज। तो आप में से जो भी लोग थर्ड ईयर, सेकेंड ईयर, फर्स्ट ईयर में हैं एंड गेट एग्जाम के लिए प्रिपेयर करना चाहते हैं फॉर 26 और 2 ईयर्स, तो आई वुड सजेस्ट कि आप 2 ईयर्स का सब्सक्रिप्शन ले सकते हो एंड यू कैन सी द प्राइस इज वेरी वेरी नॉमिनल, 24,999। ठीक है, एंड यू गाइस कैन ज्वाइन इन अ न्यू बैच अगेन विच इज स्टार्टिंग फ्रॉम 30th मई। 30th मई से हमारा एक नया बैच हम स्टार्ट करने वाले हैं। एक बैच हमने ऑलरेडी स्टार्ट किया था 17th मई को, विच वाज द प्रतिज्ञा बैच। यू ऑलरेडी नो दैट अबाउट दैट, मैंने आपको बताया था कि आप प्रतिज्ञा बैच को ज्वाइन कर सकते हो, जिसमें अभी आपका मास ट्रांसफर चल रहा है और आईपीसी चल रहा है। ठीक है, प्रतिज्ञा बैच आपका गेट 25 स्टूडेंट्स के लिए है फॉर 9 मंथ्स। और अदरवाइज आपका 30th मई से एक न्यू बैच स्टार्ट होने वाला है। एंड द बेनिफिट ऑफ हैविंग दीज थिंग्स, अगर आप 9 मंथ का, 12 मंथ का, 24 मंथ्स का ओवरऑल सब्सक्रिप्शन लेते हो तो इसका बेनिफिट ये है कि आप सभी के सभी बैचेस को एक्सेस कर सकते हो। जो भी बैच पहले बन चुके हैं या जो बैच अभी है और या जो बैच बाद में लॉन्च होंगे, आप किसी भी बैच को एक्सेस कर सकते हो। मल्टीपल टाइम्स आप उनकी रिकॉर्डिंग्स देख सकते हो, आप लाइव क्लासेस कर सकते हो किसी भी सब्जेक्ट की, किसी भी एजुकेटर की, एंड नंबर ऑफ टाइम्स, कोई प्रॉब्लम नहीं है। ठीक है, दिस इज द बेनिफिट ऑफ हैविंग दीज सब्सक्रिप्शन। यू जस्ट नीड टू गो ऑन द अनअकैडमी ऐप यूजिंग योर मोबाइल नंबर एंड सब्सक्राइब यूजिंग आर कोड। ठीक है, माई कोड इज ACE009। और अगर आप थोड़ा और ऑफर लेना चाहते हो तो यू गाइस कैन अटेम्प्ट इन दिस स्कॉलरशिप टेस्ट, जो हमारा 26 मई को होगा एट 11 AM इन मॉर्निंग, 30 मिनट्स का। ठीक है, सो इस टेस्ट में क्या होगा, इस टेस्ट में अगर आप पार्टिसिपेट करते हो और अगर आप टॉप 20 रैंक लाते हो, टॉप 50 रैंक लाते हो, तो आपको ये बेनिफिट मिलेंगे। फर्स्ट 5 रैंकर्स को 100% स्कॉलरशिप मिलेगी, 6 to 10 रैंकर्स को 50%, 11 to 20 30%, और टॉप 50 में अगर आप हो 21 से 50 के बीच में तो आपको 25% स्कॉलरशिप मिलेगी। अगेन आई एम रिपीटिंग, द टेस्ट विल बी देयर ऑन 26 मई, 11 AM। 30 मिनट्स का टेस्ट होगा, एक छोटा सा, और उसमें आपको पार्टिसिपेट करना होगा और आपके पास चांस है 100% नहीं तो 50%, 50 नहीं तो 30, 30 नहीं तो 25% स्कॉलरशिप अवेल करने का। तो गाइज, इससे अच्छा अपॉर्चुनिटी आपको नहीं मिलेगा टू गेट द अनअकैडमी सब्सक्रिप्शन एट द लोएस्ट प्राइस। ऑलरेडी एक ऑफर चल रहा है 50% का। एक स्कॉलरशिप टेस्ट है जिसमें आप एक्स्ट्रा ऑफर ले सकते हो, एक्स्ट्रा ऑफ आप स्कॉलरशिप मिल जाएगी, काइंड ऑफ फ्री पड़ जाएगा आपको। अदरवाइज आपका ऑलरेडी ये एक तरह से फ्री ही है। ठीक है, 1,000 पर मंथ का भी आपको बर्डन नहीं है इसमें। ठीक है, तो और यहाँ पर अंकुर है, मैं हूँ आप लोगों को गाइड करने के लिए, बताने के लिए, गेट 25 एग्जाम के लिए प्रिपेयर कराने के लिए। ठीक है, और बाकी एजुकेटर्स भी हैं, लाइक यू कैन सी, this was the Neev batch for the students who will prepare for gate 26. This was started on 17th May. Now one more batch will start on 30th May, तो आप उसे भी देख सकते हो। Okay, these were the rankers in our last year in 7 streams including chemical। ये हमारे स्टूडेंट्स थे जो टॉप 40 में आए थे, फ्रॉम टॉप 100 में आए थे, फ्रॉम प्लस कोर्स। यू कैन सी अंकुर सर वाज देयर and I'm also here now। So this time you will have definitely a great chance to अपने फोटो भी इस हॉल ऑफ फेम में आप अगली बार के लिए ऐड करवा लो इन डे 25। ठीक है, तो जो भी लोगों ने अभी तक स्टार्ट नहीं किया है, दिस इज माय एजुकेटर कोड, दिस इज माय टेलीग्राम चैनल लिंक, यू कैन ज्वाइन हियर, यू कैन मैसेज मी देयर रिगार्डिंग द सब्सक्रिप्शन आई वुड सजेस्ट, अगर आप सब्सक्रिप्शन लेने का प्लान कर रहे हो या स्कॉलरशिप टेस्ट देने का प्लान कर रहे हो, तो और अगर आपको कोई गाइडेंस चाहिए, आपकी कोई क्वेरी है, उससे पहले आप यहाँ पर ज्वाइन करके हमसे कांटेक्ट कर सकते हो, डिस्कस कर सकते हो। ठीक है गाइस। तो और अगर आपको सिर्फ एक सब्जेक्ट लेना है तो मेरा सीआरई चल रहा है, अभी ये कोर्स अवेलेबल है 18th 21 मई तक। आपको 2000 रुपीज में 1999 में मेरा सीआरई मिल जाएगा, जो लाइव चल रहा है अभी। उसमें जो पीछे की क्लासेस हैं वो भी आप देख सकते हो, और जो अभी चल रही हैं और आगे होंगी वो भी आप देख सकते हो, बट ओनली सीआरई इन 2000 रुपीज। ठीक है। सिमिलरली अंकुर सर का मास ट्रांसफर है, मनीष सर का हीट ट्रांसफर है, और भी बाकी लोगों का है, वो अगर आपको सिर्फ सब्जेक्ट लेना हो तो। बट अगर आप देखोगे 12 सब्जेक्ट हैं, 2000 × 12 24,000 हो जाएगा। ठीक है। और वो भी आप एक बार ही लाइव देख सकते हो। बट अगर आप 9 मंथ का या 12 मंथ का सब्सक्रिप्शन लोगे तो वो आपका 24,000 से भी कम है, हाफ है, ऑलमोस्ट 13,000 15,000 के आसपास। जहाँ पे आपको क्या करना है, बस ये कोड लगा के अपना सब्सक्रिप्शन लेना है, या अंकुर सर का कोड भी लगा सकते हो, दैट इज अंकुर 073, वॉट एवर यू लाइक। वी आर टुगेदर, वी आर बोथ सेम। ठीक है। तो आपको इससे ज़्यादा एक्सेस मिल जाएगा, आप सभी वीडियोस देख पाओगे और जितनी चाहो उतनी टाइम देख पाओगे। अगर हमारा एक मास ट्रांसफर हो गया और आपको बाद में हमारा मास ट्रांसफर या सीआरई दोबारा होता है, आप दोबारा करना चाहो तो कर सकते हैं। दैट विल बी द बेनिफिट ऑफ हैविंग दिस सब्सक्रिप्शन। अगर आप बैच वाइज जाते हो तो बैच वाइज में प्रॉब्लम है कि आप एक बैच में जो सब्जेक्ट है वही देख पाओगे, किसी और बैच में नहीं देख पाओगे। Anyways, guys, so that's all. Wish you luck. Be all the best for your scholarship test. See you in the next class. Till then, bye bye. Take care. Tada. Have a great day.